Hello. In this video, we're going to go through learning target 633, which is to evaluate composite functions. And composite just means like more than one. And sometimes that means like taking one function and plugging it into another, kind of like systems of equations. And sometimes it means like adding two together. There's lots of different composites. So it's not one template, it's lots of different things. So these are the types we're going to look at in today's lesson, but there are different ones we're going to look at in the next lesson. So it's kind of going to be split into two different sets. And this is all in function notation. And once you kind of get the hang of function notation, these will all make a lot of sense as you go through them. But basically, you're just looking for what operation the notation is telling you to do. So f and g are just the names of functions. So f and g are the names of functions. And so in this case, this just means add f plus g. And this one would then mean subtract. And subtraction, remember, order is very, very important. So addition, order is not too important, but subtraction, it's very important that you go left to right. So you do need to do f first minus g. This one, when they're squished together, just means multiply. So you're basically doing f in parentheses and g in parentheses and multiplying. And then a and then b over here are going to represent just numbers. So imagine this is like 2f of x, for example. You are going to multiply by a constant. So for example, two f of x would be multiplied by 2. And this one just kind of puts these things together. So we're adding, you could also subtract, that part's not really important, but you can see there's constants out front. So you want to make sure you multiply by the constant and add or subtract, or even multiply. So if you need to pause it to get those down, please do so. The other thing I want you to write down is this sentence. So be sure to pay attention to the order of the problem, follow PEMDAS, use exponent rules, and simplify fully. So these are the important things that you need. So again, make sure you pause it to write down that sentence if you don't have that already. So let's go through a few examples. And typically what you're going to be given is you're going to be given some functions by their name. So we're given f and g in this case. And then we need to complete some operations. So we're going to complete each of these problems. So the first thing I like to do is identify what operation we're doing. In this case, we are adding, and we're doing f plus g. The parentheses x just tells us what variable we're using. So that part's not super important for us. I'm just going to add up my f function plus my g function. And I think color coordinating these would be helpful. So I'm going to do that first one in this dark purple and the second one in this blue color. So f plus g, I'm just going to take my f function, which is everything after the equal sign, so 3x minus 1. And I'm going to add my g function, so 4x squared minus 2x plus 10. And depending on the type you're doing, you're going to follow different PEMDAS and different exponent rules. In this case, we're going to think back to when we were adding and subtracting polynomials. When you're adding and subtracting polynomials, you are only adding or subtracting the like terms. So I'm only looking at like terms. And if I'm subtracting, remember I need to add a line, so change it to addition, and change the sign and everything after. So if this was a minus sign, make sure you change it to a plus and then change everything after. In our case, we're just adding, so I'm going to find all my like terms. So 4x squared is alone, 3x and minus 2x go together, and negative 1 and 10. And I do want to put these in order from highest exponent to lowest. That should kind of be your habit after our last couple units. So I'm going to have 4x squared first. Then combine 3x minus 2x to give me plus x, or plus 1x. Then negative 1 plus 10 is positive 9. And there we go. We added our f function to our g function to get this as our answer. Now our next one is a little bit more complicated. It says 3f of x minus g, so 3f's minus g. And so I'm going to have a 3 out front, and then my f function minus my g function. And so in this case, it's very similar to this one, but before I start, I have to multiply this constant in. So I need to multiply 3 times 3 and 3 times negative 1 to get 9x minus 3. And then I can do the subtracting part. So it's important if you ever have a constant out front that you multiply first, and then you can do the addition or subtraction. So just like PEMDAS says, multiplication and division need to come first before addition and subtraction. So now because this is subtraction, I'm going to add a line and change the sign and everything after. So change this to a negative, positive, negative. And so then I'm going to go ahead and do the same thing I did over here. I'm going to find my like terms. They should be really similar, like terms, just different numbers now. And so again, I'm going to start with my x squared, but now it's a negative 4x squared. Then my x's, 9 plus 2 is 11. And negative 3 plus negative 10 is negative 13. Now my very last one is multiplication. My f and my g are just squished together, so we're going to multiply. And I do need a bit more room, so I'm going to do that one like below these two. So let's kind of do a line here. So fg of x means to multiply. So I'm going to take my f function, put it in parentheses, and then my g function right next to it, so I know that I'm multiplying. And then we do have to remember back to our rules about multiplying. You can do either the distributive method, so you distribute the 3x to all the terms, and then distribute the minus 1 to all the terms. Or we can do the box method, which I think is better because the second polynomial is a little bit bigger. So remember, for box method, I can draw a box, matching the number of rows and columns as my functions. So I'm going to have 3x minus 1 on the side and my blue function on the top. And then when I multiply, remember we add our exponents. So 4 times 3 gives me 12. 2x's and 1x is 3x's. Negative 2 times 3 is negative 6, x squared. 10 times 3 is 30, x. And then down here, these all stay the same, but their signs change because we're multiplying by negative 1. And so then I just need to pull everything out of the box in order. So I have 12x to the third. Combine these like terms to get negative 10x squared. Combine these to get plus 32x and minus 10 at the end. So now I have multiplied my two functions. So the composites that we're talking about today, addition, subtraction, multiplication, we're really going back to our polynomial unit where we're remembering how do we add polynomials where we just find our like terms. How do we subtract where we add a line, change the sign, and then find the like terms. And then how do we multiply using either the distributive method like I did here, or box method like I did here. And so once you have those operations down, this should be a good reminder of our polynomials operations that we did a couple units ago.